So in our last example, we took these two specific functions, g of x and f of x, and we composed them together to come up with this composition function, f of g of x. Now, if we take a look at this guy down here, I mean, there's a lot of stuff going on. You know, what's happening to our input? We're first subtracting 2 from it, and then whatever number that is, we are squaring it, and then whatever that is, we're multiplying it by 3, and then whatever that is, we're subtracting 6 from it, and then whatever that is, we're dividing it by 5, and then whatever that is, we are adding 4 to it. I mean, this is a really complex function with a lot of things going on. And so what I suggest is let's actually call it something. Let's call this function h of x. I'm going to do that in the upper right-hand corner up here. So let's call h of x that big function. And you know what? My claim is I bet there are other ways to compose different functions, new f of x's and new g of x's, such that when we compose them together, we get this equation right here. We'll actually get 3 times x minus 2 quantity squared minus 6 all over 5 plus 4. For instance, here's one suggestion that I have. If we let this first function g, right, this is what's going to act on our input x first. Let's let g be almost the same thing as all of this, except we're going to not include this plus 4. So if we let g of x be the function 3 times x minus 2 quantity squared minus 6 all over 5, now we need to find a different function, f of x, such that if we were to actually go ahead and insert g of x as our input, right, this whole thing, well, you say, well, what do we have to do to this whole expression to get this whole expression? Well, we need to get this whole expression again. We need to have all of this, 3 times x minus 2 quantity squared minus 6 all over 5. And then all we need is a plus 4. So it appears that all we need f to do is to take its input and add 4 to it. If that's what f did, then composing this f with this g would give us exactly the equation that we need. And so we define our function f of x to just be, well, what do you need it to do as input? Add 4 to it. So there's one pair of functions, g of x and f of x. I'm going to put them a little bit closer to one another. That will do the trick. These guys together, when we compose them, will give us that larger equation that we are looking for. Well, let's come up with another pair. So in this last example, I mean, g of x pretty much almost did everything that we wanted our composition to do. All f needed to do is just add 4 at the end. Well, we can do something pretty similar. What if we let g of x be, I don't know, what's it going to do to our original input x? We'll have it do 3 times x minus 2 quantity squared minus 6. And so we say, okay, well, we need a function f. And what do we need that function to do? Well, we need it to be the case that when we plug g of x into it, we need to take this whole thing, this 3 times the quantity of x minus 2 squared minus 6. Well, that's our input. What do we need f to do to that input? We need it to divide everything by 5 and then add 4. And if that's the case, then composing them together will give exactly what we're looking for. And so we say, okay, well, f of x, what should that function be? All we want it to do to its input is divide by 5 and then add 4. So we're going to call f of x the function where if you give it an input, it immediately divides by 5 and then adds 4. All right, so we have yet another pair of functions that will do just that. I'm going to kind of clump them together again. Awesome. And I claim we can find even another one. So give me a second. I just kind of want to circle these guys so we can keep everything in organized. So here's another one. What about this? What if we called g of x, and maybe you'll see a pattern here. What if we called g of x the function, well, whatever you plug into g, we'll do x minus 2 quantity squared. We'll do 3 times x minus 2 quantity squared. Give me a second to fix this. 3 times x minus 2 quantity squared. And now we got to say, all right, we need f of g of x to give us this big old equation right here. So what do we need to do to this expression to get this up here? Well, we need our function f of g of x. So what does f got to do to g of x? Well, it's got to take g of x, and it has to add 6 to it. And then it needs to take that and divide it by 5. And then it needs to take that and add 4. And so we said, oh, well, what did f do to its input? All it did to its input was add 6, divide everything by 5, and then add 4. And so we say that our function f of x in this case will be the function x plus 6 over 5 plus 4. And we have come up with yet another pair of functions that will do exactly what we want them to do. And so I'm going to create another page and show kind of what's been going on in this case. So let's explore what's been going on behind the scenes here. So here's our big function h of x, and we're trying to compose two functions to get there. And what I first want to do is think, well, if we were to actually insert a number for x, like 4, what would we do to that number in order to actually evaluate this whole expression? Well, my claim is that whatever that number is, the first thing we do is subtract 2 from it. So I'm going to write that as minus 2, right? We're subtracting 2. And then we would take this whole quantity and we would square it. So I think the second operation that's happening is a squaring operation, so raising to the second power. Then whatever this quantity is, we're multiplying by 3. So I think the third operation is multiplying by 3. And I believe that after you have this whole quantity, the next thing we're doing is we're subtracting 6 from it. So I believe our next step is subtracting 6. Then when we have this entire quantity up here, we divide the whole thing by 5. So the next operation that's happening to this quantity that we have, after all those other operations happened, was dividing by 5. And last but not least, when we have this entire big old expression, whatever that is, whatever that quantity is, we add 4 to it. So the very last operation that happens to our input is adding 4. So look, I mean, we got 1, 2, 3, 4, 5, 6 operations going on here with our function h of x. And so what we need to do is figure out, okay, how can we make more functions such that when we compose them together, this h of x is what we get. Now, to be quite frank, the very first example that I gave last time, my first function, so we're trying to find two functions, f of g of x, that when we compose them we get h of x. Now, my very first example that I gave, our first function, f of x, actually took care of all of these steps. Remember, f of x was equal to x minus 2 quantity squared 3 times that minus 6 all over 5. And if you scroll back in the video, you'll see just that. And then our next function, g of x, just said, oh, I'm going to pick up where you left off. I'm going to take all of you, all of that, and I'm going to add 4 to it. Right, but we write just x plus 4 because, excuse me, this should be a, oh geez, pardon me. This one should be a g of x over here. I apologize, and this one should be an f. I hope that's okay. Pardon me. Right, why? Because when we do f of g of x, right, this g of x is inserted for that x, this whole expression, and of course when you add 4 to it, you'll get exactly what you want. Then we did another example, and the next example I did actually did almost as much. I hope you can kind of see where this is going. My next example that I did actually just went to here. Our initial function g of x was just x minus 2 quantity squared 3 times all of that, minus 6. And that was it. Right, so it took care of the subtracting by 2. It took care of the squaring. It took care of the multiplying by 3. And it took care of the subtracting by 6. What did it not take care of? It did not take care of the dividing by 5 and adding 4 in that order. And so our function f of x in this case was take your input, divided by 5, and then add 4. And the third example that I gave was, well, our first function did the first 3 operations. Our original function was g of x equaled x minus 2 quantity squared, 3 times that. And so our second function, f of x, had to pick up where g left off and do the remaining operations. Right? G took care of the subtracting by 2, g took care of the squaring, and g took care of the multiplying by 3. And so f of x had to take care of the subtracting 6, dividing 5, and adding 4. And so f of x says, take your input, subtract 6 from it, divide by 5, and add 4. And so I urge you to see, can you come up with maybe 1 or even 2 more different ways to decompose this big function?